In this video, we will be discussing about balancing of chemical equation. This is a topic from class 10 of the chapter chemical reactions and equations. So, the first thing comes into mind is why is there a need to balance a chemical equation? Why is it required to balance a chemical equation? So, the reason for the balancing of the chemical equation is to follow the conservation, law of conservation of mass. So, to follow the law of conservation of mass, we need to balance a chemical equation. Why? So, what the law of mass conservation says? The law says that the mass can neither be created nor be destroyed. So let us note it down. Mass can neither be created nor be destroyed. Mass can neither be created and nor be destroyed. And to follow this thing, the number of atoms of each element present on each side of the chemical equation should be equal. Number of atoms of each element on both sides of equation should be equal. So let us have a look over a equation. We have Mg plus O2 giving MgO. Magnesium is our solid, oxygen is the gas, and MgO is a solid. So if you have a look over this equation, then you can see. Let us have a look over the masses. So we have one magnesium atom here, so the mass is 24 grams. Two oxygen atoms are there, so it is 32 grams, which makes a total of 56 grams. And the product is MgO, the mass of which is 40 grams. So you can see that the mass of the reactants is 56 grams and the mass of the product is 40 grams, which is not balanced. So this equation do not follow the law of mass conservation. So this equation needs to be balanced. We balance the equation if you note this equation as, if you multiply 2 here, it makes 2 MgO, and if you write 2 here, then the number of magnesium atoms on the left hand side is 2, oxygen atoms is 2, and the number of magnesium and oxygen atom on the product side as well is 2 only. If we consider the mass, then mass of 2 magnesium atom will be 2 into 24, which makes 48 grams. The mass of oxygen is 32 grams, which makes the total mass on the reactant side as 80 grams. And the mass of one magnesium oxide is 40 grams. So we have 2 MgO here, which makes it as 2 into 40 is equals 80 grams. So here, by balancing the number of atoms on each side of the equation, the mass gets balanced on both the side and the law of mass conservation gets followed. So the need to balance a chemical equation is what? To follow the law of mass conservation. So let us have a look over the steps which needs to be followed while balancing a chemical equation. So let us have an equation. The equation is Fe plus H2O gives Fe3O4 plus H2. So we have an equation here. So what are the steps that needs to be followed are as follows. Step 1 is you have to count the number of atoms of each element on both the side of the equation and represent them in a tabular form. We have a table here, so we will be representing the number of atoms of each element on both sides of the equation in a tabular form. So let us note down the step. Count number of atoms of each element on both sides of chemical equation and represent it in tabular form. So we note down the elements here. Atoms on the reactant side and number of atoms on the product side. So what are the elements present in this chemical equation? We have iron, we have hydrogen, and we have oxygen. So the number of iron atoms on the left hand side equation is 1, on the reactant side is 1, so we note it down as 1. The number of iron atoms on the right hand side of the equation is 3, that is the product side is 3. The number of hydrogen on the left hand side of the equation is 2, on the right hand side of the equation is 2 as well, and the number of oxygen atoms on the left hand side is 1, and on the right hand side it is 4. So this is our first step. We counted the number of atoms of each element on both sides of the equation and represented them in a tabular form. So let us proceed to the step 2. Balance the atom which is largest in number on both sides. So the equation was Fe plus H2O gives us Fe3O4 plus H2. So the number of oxygen atoms were the highest. It is 4 on the left hand side and 1 on the 4 on the right hand side and 1 on the left hand side. So we choose to balance the oxygen atoms first. So for balancing the oxygen atom, we will be multiplying 4 to the H2O molecule so that there will be 4 oxygen atoms on the left hand side and there are 4 oxygen atoms on the right hand side as well. So this is our step 2 and the number of oxygen atoms gets balanced. Now the next step is to balance the remaining atoms. Balance the remaining atoms. So if you have a look over this equation, you have 3 iron atoms on the right hand side and only 1 iron atom is present on the left hand side. So we note it as 3Fe plus 4H2O gives Fe3O4 plus H2. So now the iron as well as oxygen atoms are balanced. Let us have a look over hydrogen atom. There are 8 hydrogen atom on the left hand side of the chemical equation and only 2 hydrogen atom on the right hand side. So to balance the hydrogen atom, we will multiply 4 to the H2, which makes the equation as Fe3O4 plus 4H2. So if you have a look over this equation, then you will be getting 3 iron atoms on the left hand side, 3 iron atoms on the right hand side, 8 hydrogen atoms on the left hand side, 8 hydrogen atoms on the right hand side, 4 oxygen atoms on the left hand side, and 4 oxygen atoms on the right hand side. All the atoms are balanced now. So we get the balanced equation. The last step to be followed is to represent the state in which these elements are present in the chemical equation. So iron is solid. So we will denote the state as 3FeS. H2O is used in a steam form here, gas. Fe3O4 is a solid, and H2 is gas. So this is our final balanced equation. So this is how we balance a chemical equation. These are the steps for the balancing of a chemical equation. Thanks for watching this video.